This course provides an overview of the characteristics of 100% acrylic solid surface compared to other surface materials, and the driving forces that contribute to its growing role in sustainable design strategies. Also discussed are the manufacturing, fabricating, and thermoformable processes of 100% acrylic solid surface and the related green standards and certification programs. Learning objectives. At the end of this program, participants will be able to compare the characteristics, durability, and life cycles of the current principal surface materials used for commercial installations. Summarize the manufacturing, fabrication, and thermoforming process of 100% acrylic solid surface. State the factors relating to the design, aesthetics, performance advantages, and green features that are driving the upward demand for solid surface solutions for commercial installations. And finally, discuss the relationship of 100% acrylic solid surface to the LEED Green Building Certification Program, Scientific Certification Systems (SCS), and Green Guard, as well as the applications and the variety of uses of solid surface in interior commercial markets. How to use this online learning course. To view this course, use the Play/Pause button on the video player. To receive a certificate indicating course completion, refer to the instructions at the end of the video. Course topics include an overview of surface materials, manufacturing acrylic solid surface, acrylic solid surface features and benefits, acrylic solid surface applications, and a summary of what was covered. An overview of surface materials. Introduction. Today's architects, designers, and builders are faced with a myriad of options when specifying surface materials. Making suitable choices can be even more daunting when you add the environmentally conscious movement for green and sustainable solutions. This course begins with an overview of the characteristics of principal surfaces currently used today and the pros and cons of each material. Let's quickly look at each of these options. High-pressure laminate, or HPL. Plastic laminate is the most common and most widely used surface because it is relatively inexpensive and is available in a wide variety of design choices. However, plastic laminate is easily chipped and scratched, may delaminate when exposed to moisture, and is difficult to repair. Many times, damage results in a complete replacement. In addition, laminate has a low fire rating when compared to other interior surfacing materials. Pros. It's inexpensive and has extensive design choices. Cons. It may delaminate when exposed to moisture, easily chipped or marred. Damage requires replacement. Shorter than average life cycle, low fire rating, and it's not NSF, National Sanitation Foundation certified laminate. Ceramic and stone tile. Although ceramic and stone tile have great design flexibility and are extremely resistant to heat, these types of surfaces can trap dirt, bacteria, and mold in open seams and grout lines. In addition, the grout can crack easily, allowing moisture to penetrate and giving bacteria and mold a place to grow. Consequently, the grout must be properly maintained and cleaned for hygienic and aesthetic purposes. Pros. Design flexibility. It's heat resistant. Cons. Seams trap dirt, bacteria, and mold. Grout must be cleaned. Grout frequently cracks, allowing moisture to penetrate. Tile can crack easily from impact, and it's not NSF approved. Natural stone and marble. Natural stone and marble are great natural materials, combining beauty with design flexibility. They are available as slab and tiles and are heat resistant. Note that natural stone and marble are porous and can become stained even when sealed properly. In addition, seams can harbor bacteria and mold long before they are noticeable. While aesthetically pleasing, these types of surface materials can crack from impact and are considered difficult materials to repair. In certain applications, natural stone and marble solutions can be cost prohibitive. Pros. It's aesthetically pleasing, has design flexibility, and heat resistant. Cons. It's porous, staining. Seams trap dirt, bacteria, and mold. Grout must be cleaned. Grout frequently cracks. Moisture penetration. Material can crack from impact. Can be costly. Not NSF approved. Stainless steel. Generally, stainless steel is relatively low maintenance and durable. Stainless steel scratches, can be dented, is cold to the touch, and is visually cold. As a result, stainless steel has somewhat limited design appeal. Pros: it's low maintenance, extremely durable, and it's NSF approved for use in restaurants and hospitals. Cons: it scratches and dents, has a cold look and touch, and has limited design appeal. Quartz, engineered stone. Engineered stone is a surfacing material that is well suited for applications where a hygienic surface is required because it is scratch resistant, non-porous, and NSF approved. However, because quartz engineered stone is installed in a similar way to natural stone slabs, engineered stone installations may have slightly open seams that can be susceptible to moisture penetration and bacterial growth if not properly maintained. Pros include pleasing aesthetics, wide color selection, Class 1 fire rating, scratch resistant, non-porous, hygienic, and it's NSF approved. Cons: some design limitation, must be fabricated by specialized contractor, price, not easily repaired. Solid surface. Solid surface is a composite material that is manufactured by blending acrylic or polyester resin with organic fillers and pigments. The fillers, basically the bulk of the material, are analogous between acrylic and polyester solid surface. It's the quantity of acrylics or polyesters within the resins that will vary. Solid surface material chemically cures to form a homogeneous surface that is versatile and durable and offers many design benefits with few detracting features. Types of solid surface. Polyester solid surface is commonly manufactured in a high gloss finish and is generally more translucent when compared to acrylic solid surface materials. However, because of the polyester content, it tends to be brittle. Many polyester solid surface products do not carry a Class 1 fire rating. Acrylic solid surface has greater tensile and flexural strength, and it offers higher heat and impact resistance than polyester solid surface. Acrylic offers an easier seaming process, lends itself more to thermoforming, and can be bent to tighter radii. This section of the course ends with a summary of the pros and cons of acrylic solid surface material, which will be reviewed in greater detail further along in the course. Pros: has pleasing aesthetics and a wide color selection, is durable and repairable, non-porous, hygienic, NSF approved, imperceptible seams, easy to clean and sanitize, increased design flexibility, Class 1 fire rating. Cons: must be fabricated by specialized contractor, has high upfront cost when compared to plastic laminate solid surface. The next section of the course presents an overview of the manufacturing, fabrication, and thermoforming process of acrylic solid surface. Acrylic solid surface is a homogeneous non-porous surfacing material composed of 1/3 acrylic resin, called polymethyl methacrylate, PMMA, and 2/3 aluminum trihydroxide, ATH, a natural mineral derived from bauxite. Pigments and other additives, example chips, are incorporated into the acrylic resin mix to enhance the overall color and design appearance. For some manufacturers, the production line has a capability to shake or oscillate to certain levels to create free-flowing or vein-style designs. The mixture of these properties forms the core components that allow the solid surface sheet material to resist exposure to the effects of heat, as well as resist damage caused by accidental impact. Solid surface sheet dimensions. Solid surface sheets are typically 1/4 or 1/2 inch thick, 30 inches wide, and either 145 or 98 inches long, as shown on this chart. Sheets are available in an extensive range of colors and patterns. Fabrication of solid surface. From the manufactured sheets, the finished solid surface product is fabricated by a certified subcontractor. Here is the process. Template is made. Sheets are cut and routed to specific dimensions. Sheets and sections are joined with nearly imperceptible seams. Edges are glued and machined to a specific profile. Surface is sanded and buffed to a matte or satin finish. Backsplashes can be deck mounted or coved. Solid surface sinks are seamed and undermounted beneath the counter for integrated one-piece construction. 100% acrylic solid surface can be thermoformed for special design applications. Thermoforming of solid surface. Material preparation is very important for successful thermoforming of solid surface. All pieces are cut to their required dimensions, allowing for material shrinkage and expansion during thermoforming, then sanded to a matte finish. When designing, depending on the solid surface product, the minimum inside radius thermoformed as per solid surface thickness can range as shown on this chart. Molds are generally made from plywood or medium density fiberboard, MDF, in male-female sections to hold the heated sheet in the desired shape. Solid surface material is heated to a temperature between 293 degrees Fahrenheit, 145 degrees Celsius, and 347 degrees Fahrenheit, 175 degrees Celsius, for thermoforming. Lower temperatures may crack and whiten the material, and higher temperatures can result in blistering, whitening, or cracking. The oven must be correctly prepared and calibrated, and the oven temperature should not exceed 347 degrees Fahrenheit or 175 degrees Celsius. Depending on the oven and the size of the piece to be thermoformed, the oven temperature and dwell time may vary. Therefore, before thermoforming solid surface materials, it's recommended to calibrate the oven with a sample piece of the material. Acrylic solid surface. Features and benefits. Introduction. The use of solid surface for a variety of commercial interior installations is growing due to its many benefits. What's driving demand? Design advantages, performance advantages, and green features. Each of the points above will be reviewed in this section of the course. Design advantages. Acrylic solid surface is an attractive design solution, delivering enhanced aesthetics combined with superior properties. The design flexibility of solid surface material enables the design community to craft inspiring works to suit their clients' standards. It's readily thermoformed to create custom curves, shapes, and designs to suit any decor environment. Freeforming of three-dimensional representation is possible, bringing another layer of depth and sophistication to a range of applications. Range of colors and patterns. The newest generation of acrylic solid surfaces provides a contemporary aesthetic combined with all the benefits of 100% acrylic. From simple solid color tones to modern interpretations of linear and chip-based patterns, acrylic solid surface materials can facilitate a wide range of interior commercial uses, including horizontal and vertical applications. Acrylic solid surface is ideal for many commercial segments, as these types of environments generally are considered high-traffic, high-use areas. Contemporary solid colors. A variety of light solid colors are available, including a range of brilliant white, soft pastels, and natural tones. Options for dark solid colors include variations of black, gray, and metallic tones. Sanded colors. These colors feature small, sand-sized particles in varying degrees of depth and visibility, adding visual texture to the surface. Chip patterns. A chip pattern is made with enhanced, engineered particulates that create patterns with exceptional depth and translucency throughout. Free-flowing vein patterns. Inspired by natural stone, these contemporary colors feature distinct wave patterns in different hues and clarities. Recycled series. Available in the market are acrylic solid surfaces that are manufactured using pre-consumer recycled content, resulting in a reduction of industrial waste and energy consumed during the manufacturing process. Using recycled content helps conserve energy and resources, alleviates pressure on landfill space, and reduces the need for transportation during certain phases of a product's life cycle. Edge profiles. A range of solid surface decorative edges are available that can be used to further accentuate and define each project. Edge treatment options range from a simple rounded corner to complex multi-tiered edges. Performance advantages. Acrylic solid surface is suitable for a wide range of commercial environments. Listed here are the performance advantages of solid surface materials. Non-porous and hygienic. When fabricated and installed with imperceptible seams, solid surface is ultra-hygienic and easy to maintain. Because solid surface is a non-porous material, bacteria, viruses, fungi, and mold will not permeate its surface. As a result, solid surface is NSF approved as a food preparation surface. Providing a healthier and hygienic environment, acrylic solid surface is a preferred material in healthcare-oriented environments, such as hospitals, medical clinics, and long-term care facilities. Low-maintenance acrylic solid surface has an exceptionally long life cycle when properly maintained. To preserve solid surface products, always follow the manufacturer's recommended care instructions. General cleaning of acrylic solid surface is facilitated by wiping the surface with a damp cloth or sponge combined with a non-abrasive cleaning agent. Then dry with a soft cloth or paper towels to prevent the appearance of hard water stain marks. Surface dried stains can be easily removed with an ammonia-based product, such as household glass cleaner or commercially available non-abrasive spray-on cleaners. Wipe dry with a soft cloth or paper towels to prevent spotting. As a homogeneous, color-through material, acrylic solid surface is repairable and renewable. Even after years of use, it can simply be sanded to restore it to its original condition. Long life cycle. Compared to other composite interior finish materials, solid surface has an above-average life cycle expectancy. Due to the long-term durability and repairability of acrylic solid surface, it is a smart investment for high-use areas when the following factors are considered: price per foot, installation cost, maintenance costs, durability and longevity, appearance over time, and refurbishment to new condition. Horizontal and vertical applications. Acrylic solid surface material is suited to both horizontal and vertical applications such as wainscoting, partitions, store fixture displays, and much more. Green features. The next topic for discussion is the green features of acrylic solid surface. Topics include SCS certification, Health Product Declaration, HPD, Green Guard, and LEED. Scientific Certification Systems, or SCS, is a global leader in independent certification of environmental and sustainability claims. For more than 2 decades, SCS has developed internationally recognized standards and certification programs aimed at spurring the highest level of environmental improvements, social accountability, and product performance. SCS programs span a wide cross-section of the economy, recognizing accomplishments in agricultural production, food processing and handling, forestry, fisheries, flowers and plants, energy, green building, consumer and business product manufacturing, and corporate social responsibility. The SCS Material Content Certification verifies that the product manufacturer is working responsibly to minimize environmental impact during the manufacturing process. Some manufacturers offer a range of solid surface products that are SCS Material Content certified. These products contain a percentage, 5 to 30%, of pre-consumer recycled materials that are diverted from the waste stream, resulting in a reduction of industrial waste and energy consumed during the manufacturing process. Using recycled content helps conserve energy and resources, alleviates pressure on landfill space, and reduces the need for transportation during certain phases of a product's life cycle. For more information, refer to www.scscertified.com. Health Product Declaration, HPD. Building professionals, including designers, architects, and specifiers, are increasingly interested in obtaining information on the material ingredient content of a building product and the health risks associated with exposure to these elements. The HPD standard is developed and managed by the HPD Collaborative, a nonprofit organization. The HPD Collaborative created, supports, and evolves the Health Product Declaration, HPD, an open standard format for the accurate reporting of material contents and potential health hazards. Some acrylic solid surface products meet the HPD standard as no heavy metals or toxic chemicals are used in the production process. Green Guard certification. Several brands of acrylic solid surface have passed the requirements of 2 Green Guard certification programs. Green Guard Indoor Air Quality Certified product certification is granted for low-emitting interior building materials, furnishings, and finish systems. Green Guard Gold certification, formerly referred to as Green Guard Children in Schools, is the more stringent certification, ensuring that a product is suitable for use in environments such as schools and healthcare facilities. The Green Guard Gold certification is referenced by both the Collaborative for High Performance Schools, CHPS, and the Leadership in Energy and Environmental Design, LEED Green Building Certification Program. Any architect, builder, or developer who includes Green Guard certified products in commercial, institutional, or multifamily housing projects may qualify for points toward LEED 2009 for commercial interior certification in its Environmental Quality EQ 4.5 section. LEED and Solid Surface. Solid surface products certified by SCS help meet the criteria for the LEED 2009 and LEED v4 Green Building Certification Program as specified by the U.S. Green Building Council. Specifying solid surface products may help earn LEED points in the following categories as shown here in this chart. LEED for new construction and major renovations. The following information will assist architects, specifiers, and designers who pursue the LEED for new construction and major renovations rating system using solid surface products as components to interior architecture, casework, and surfaces. LEED for new construction and major renovations rating system is a set of performance standards for certifying the design and construction of commercial or institutional buildings and high-rise residential buildings of all sizes, both public and private. The objective is to promote healthful, durable, affordable, and environmentally sound practices in building design and construction. LEED for new construction and major renovations materials and resources, MR Credit 4, intent. To increase demand for building products that incorporate recycled content materials, thereby reducing impacts resulting from extraction and processing of virgin materials. Requirements. Use materials with recycled content such that the sum of post-consumer recycled content plus of the pre-consumer content constitutes at least 10 or 20% based on cost of the total value of the materials in the project. Potential technologies and strategies. Establish a project goal for recycled content materials and identify material suppliers that can achieve this goal. During construction, ensure that the specified recycled content materials are installed. The recycled content value of a material assembly is determined by weight. The recycled fraction of the assembly is then multiplied by the cost of assembly to determine the recycled content value. Mechanical, electrical, and plumbing components and specialty items, such as elevators, cannot be included in this calculation. Include only materials permanently installed in the project. Furniture may be included if it is included consistently in MR Credit 3, materials reuse through MR Credit 7, certified wood. Some brands of solid surface products can help to earn LEED credits in this category. LEED for new construction and major renovations materials and resources, MR Credit 3, materials reuse, intent. To reuse building materials and products to reduce demand for virgin materials and reduce waste, thereby lessening impacts associated with the extraction and processing of virgin resources. Requirements. Use salvaged, refurbished, or reused materials, the sum of which constitutes at least 5 or 10% based on cost of the total value of materials on the project. Potential technologies and strategies. Identify opportunities to incorporate salvaged materials into the building design and research potential material suppliers. Consider salvaged materials such as beams and posts, flooring, paneling, doors and frames, cabinetry and furniture, brick, and decorative items. Some solid surface products are easily repaired or refinished to original condition, thus minimizing replacements or disposal. These surfaces may also be redesigned and refabricated into entirely new products. LEED for new construction and major renovations, ID Credit 1, Innovation and Design, intent. To provide design teams and projects the opportunity to achieve exceptional performance above the requirements set by the LEED Green Building Certification Program, and/or innovative performance in green building categories not specifically addressed by the LEED Green Building Certification Program. Requirements. Credit can be achieved through any combination of the innovation in design and exemplary performance paths. Potential technologies and strategies. Apply strategies or measures that demonstrate a comprehensive approach and quantifiable environment and/or health benefits. Engineering of finished products incorporating solid surface materials may help reduce waste through custom sizing while also reducing labor. The materials may also be integrated into modular designs allowing for additional flexibility. Acrylic solid surface applications. Introduction. Acrylic solid surface is accepted globally as a premium material for commercial spaces and other specialty applications. The features of solid surface reviewed in the previous section are driving the growth of solid surfacing in the commercial segment. Commercial applications of solid surface: healthcare facilities, medical clinics, education, multifamily housing, food service, hospitality, corporate offices, institutional, retail fixtures, and displays. Presented in this section are examples of commercial applications. Education. Due to heavy wear and tear, typical in K-12 and higher education settings, solid surface is a durable and repairable finish option. Typical installations include work surfaces, shower stalls, kitchens, kitchenettes, classroom labs, medical clinics, public restrooms, and student eateries, cafeterias, and transaction counters. Food service, hospitality, and lodging. Solid surface is one of the few materials that is approved for use in commercial food service areas. It is used in a variety of applications in hospitality, including food preparation surfaces, transaction counters, condiment and beverage stations, bar tops and tabletops, restroom vanity tops and toilet partitions, shower walls and guest room vanity tops, chair molding, ledges, and windowsills, elevator cab interiors, and kiosks and signage. The durable nature of acrylic solid surface makes it the perfect surface solution for the food service industry, as it is a safe surface for all food contact areas. Its renewable and repairable nature makes it suitable for high traffic areas, such as benches, tables, and serveries, as it will keep its aesthetic appeal for many years. No open joints also means that there will be no food trapping crevices and bacteria grime buildup, just one clean, continuous surface. The versatility of acrylic solid surface enables the product to be used in the lodging segment, in the lobby, registration desks, restrooms, reception areas, restaurants, elevator cab interiors, and more. Office. When used in an office environment, acrylic solid surface offers a clean and hygienic surface to fit a variety of areas. The hygienic properties of acrylic solid surface provide a clean workspace and negate cross-contamination or the spread of bacteria. The monolithic and thermoformable properties of acrylic solid surface enable extraordinary design flexibility and can be used to transform an office space into a user-friendly and ergonomic environment. Corporate applications of solid surface include reception counters, workstations, windowsills, cafeterias, break rooms, public restrooms, as well as wall protection and guardrails. Retail. Creating the right environment for consumers is key to the success of any store. The thermoformability and color range of acrylic solid surface can provide designers with the tools needed to create exciting yet functional fixtures and displays for a wide range of shopping environments. Consumer products can be beautifully displayed to great effect within an acrylic solid surface open cabinet or on a shelf or pedestal, especially when they are combined with clever lighting effects. Institutional. Solid surface is also ideally suited for institutional applications such as museum, displays interactive, kiosks, libraries, study halls, recreation centers, and sporting facilities. Healthcare facilities. Healthcare applications of solid surface include nurses' stations, examination areas, patient rooms, restrooms, cafeterias, reception areas, labs, and various vertical applications. Solid surface has gained wide acceptance as the surfacing material of choice for healthcare interiors due to its hygienic properties and repairability. It can be sanitized easily and does not have open joints or seams that can trap bacteria and moisture. Healthcare facilities are one of the most viable market segments for solid surface. Reasons include growing health concerns and HIPAA, Health Insurance Portability and Accountability Act. Hospitals are the most complex of building types. Each hospital is composed of a wide range of services and functional units, as shown here. Healthcare facilities. Design prerequisites: cleanliness and sanitation. Healthcare facilities must be easy to clean, maintain, and sanitize. Materials used should be renewable and resistant to bacteria and mold to avoid the spread of disease. Durable finishes are required for each functional space, including transitions, to avoid dirt catching and hard-to-clean crevices and joints. Healthcare facilities. Design prerequisites: therapeutic environment. The overall surroundings have a direct impact on the occupants. Therefore, it's important that the design and decor of the space maximizes patient comfort and minimizes stress. Using materials that vary by color and texture, yet are appropriate for the setting, is recommended. Healthcare facilities. Design prerequisites: aesthetics. Aesthetics plays an important role in enhancing a healthcare facility's image, from intimate, home-like patient rooms to professional office spaces. Factors to consider include using natural-looking materials and textures, giving attention to proportion and color, as well as increasing the use of light. Healthcare facilities. Design challenges. Healthcare facilities face great challenges when it comes to design aesthetics and the well-being of patients. A balance must be struck between the aesthetic appearance of the space and design standards for healthcare settings. In summary, materials must meet specific standards and requirements for the environment and be able to withstand the high demands of everyday use. At the same time, the interior architecture and decor must convey a feeling of comfort and well-being. Standards in healthcare facilities. The complexity of healthcare is reflected in the breadth and specificity of regulations and codes that pertain to hospital construction and operations. Each of the organizations listed here have stringent standards on the spread of infectious disease and guidelines governing the construction and design of healthcare facilities. The commonality is that all standards are calling for greater emphasis on hygiene and the specification of materials that do not promote or support bacterial growth and the spread of infectious disease. In this course, a review of the pros and cons of designing with various surface materials, including 100% acrylic solid surface, was presented. Made from acrylic polymers, inorganic filler, and pigments, acrylic surfacing materials offer an array of benefits, including an impressive range of variegated colors to complement a range of interior designs. The factors that are driving the increased demand for solid surface for commercial interior use include design aesthetics, performance advantages, and green features. Offering tremendous design flexibility, thermoformable solid surface can be easily crafted into custom designs. Solid surface products certified by SCS help meet the criteria for the LEED Green Building Certification Program as specified by the U.S. Green Building Council. Commercial applications of solid surface include education, food service, hospitality, lodging, office, retail, institutional, and healthcare facilities. Conclusion. If you desire AIA, CES, state licensing, or CE credits for another organization, please click on the button to commence your online examination. A score of 80% or better will allow you to print your certificate of completion. You may also go to your daily transcript to see your completed courses and certificates. For additional knowledge and post-seminar assistance, click on the Ask an Expert link above. If you have colleagues that might benefit from this seminar, please let them know. Thanks for watching and learning.